Dear friends, here we will discuss about problems on circles. From exercise 10.4. Two circles of radii 5 cm and 3 cm intersect at 2 points and the distance between their centers is 4 cm. Find the length of the common chord. Here, two circles of radii. The bigger circle, the radii, we can assume that it is 5 cm. And the smaller circle it is 3 cm. And the 2 points, they will intersect at 2 points. So, they are intersecting at 2 points P and Q. And the distance between their centers, so distance from O to O dash is 4 cm. We need to find the length of the common chord. So, that we have to find the length of PQ. Here what is given? Given that OP equal to 5 cm, O dash P equal to 3 cm, and O dash distance between their centers is 4 cm. So that we have to find the length of PQ. So here, in these two circles, in these two triangles, we are getting the triangle. If we join OP and O dash P to the chord, the common chord, and the line joining the centers of both of the circles. So only these two lines we have. So if we join OP and O dash P, OP is the radius of the first circle and O dash P is the radius of the second circle. We know very well that the common chord, okay, for this, the line drawn through the centers of the circle is the perpendicular bisector of the common chord. So, definitely it is a perpendicular bisector of the common chord. It will make 90 degree as well as this line joining through the centers of the circle bisect the chord. It is the perpendicular bisector of the common chord. So, which implies that O dash is perpendicular to PQ as well as it bisects PQ. So, that if we take the center point as L, so PL equal to LQ. This we know very well according to theorem. The line drawn through the centers of the chord is the perpendicular bisector of the common chord. So that it is a right angled triangle. The distance from O to O dash is 4 cm. So let we assume O dash L equal to X. So this distance, if we consider it as X, so that O dash L is X and OL become the total length is 4. So we will get 4 minus X. So this distance is 4 minus X and this distance is X. So it is a right angle triangle. Both are right angle triangle. We have hypotenuse on the one side of both of the triangle. So we can substitute Pythagoras theorem here. So in triangle OPL, in this triangle, so according to Pythagoras theorem, OP square equal to OL square plus PL square. OP is 5 square. So 5 square equal to OL square is 4 minus X the whole square plus PL square. So here PL only the unknown thing. So let we bring to the left hand side. So PL square plus 4 minus X the whole square equal to 5 square. So that PL square equal to 5 square minus 4 minus X the whole square. Let me keep this as equation 1. And from the second triangle, in triangle O dash PL, here also we can substitute Pythagoras theorem that O dash P square equal to O dash L square plus PL square. So O dash P square is 3. So 3 square equal to O dash L square is X square plus PL is unknown. So PL square. PL only unknown. So let me change the side. So PL square plus x square equal to 3 square. So that PL square equal to 3 square minus x square. X square. So let me keep this as equation number 2. Here both of the left hand side is PL square. So we can equalize the right hand side. So that 5 square minus 4 minus x the whole square equal to 3 square minus x square. Here this bracket if we expand, 5 square become 25 minus of this bracket if we expand, a minus b the whole square form it. So a square 16 plus x square minus 2ab. 2 4s are 8, 8x we will get equal to 3 square become 9 minus x square. So we can remove the bracket now. So 25 minus 16 minus x square plus 8x is equal to 9 minus x square. So 25 minus 16 become 9. So 9 plus 8x. Here this minus x square, this minus x square. Same sign in the opposite side will become cancel. So 9 plus 8x is equal to 9. That means 8x equal to 9 minus 9. So 8x is equal to 0. That means x is equal to 0. We are getting x is equal to 0. What is x? X is the distance from the second circle to the center of this common chord. So O dash L equal to 0. So O dash L equal to 0 if we take that if we substitute x value in any of these two equations, we will get the value of PL. So this is a little bit bigger, so let me substitute this x value in this equation so that we will get PL square equal to 3 square become 9 minus x square become 0. So PL square equal to 9. That means if we take square root on both sides, we will get PL equal to 3 centimeter. It is given in terms of centimeter only. So PL is 3 centimeter. We know very well that PL equal to LQ. PL equal to LQ. Why? Because O dash is the line joined through the center of the circle is the perpendicular bisector of the common chord. So that PL equal to LQ as well as PL plus LQ equal to PQ. This PQ only we have to find out. So we have got that now PL, what is the value of PL? Is 3 centimeter. We arrived now that PL equal to 3 centimeter. So that let me substitute in this equation for getting PQ. So PQ is PL plus LQ. And both are equal. So this is also 3 and this also 3. It will become 3 plus 3 6 centimeter is the length of the common chord. So the length of the common chord PQ equal to 6 centimeter. Length of the common chord PQ equal to, we need to find the length of the common chord. So length of the common chord is 6 centimeter. So PQ is 6 centimeter. Next question. If two equal chords of a circle intersect within the circle, prove that the segment of one chord are equal to the corresponding segments of the other chord. So each and every segment we have to prove that they are equal. Segment of one chord. That means here AB is a chord. If we take the chord AB, it has more segments. The segments are AB also one segment, the whole line segment, and AM, AE, ME, MB, So these are all the different segments in this segments on this chord. The corresponding segments if we take in the other chord, for AB the corresponding segments of that chord will be CD. For AM it is DN. For AE it is DE. And for ME it is NE. And for MB it is NC. So we have to prove that segments of one chord are equal to corresponding segments of the other chord. So these corresponding segments are equal, we have to prove. This only we need to prove. So for this, what is given? Two chords, two equal chords. That is, the chords AB equal to chords CD. Two equal chords intersect within the circle, intersecting at the point E. So the point E is the intersecting point. So that we have to prove the corresponding segments of both of the chords are equal. So for that, let we draw perpendiculars. Draw perpendiculars OM to AB and ON to CD from the center of the circle. So perpendicular drawn from the center of the circle bisect the chord. That we know very well. So perpendiculars drawn from the center of the circle is a bisector of the chord. So what will happen? OM is perpendicular to AB, which implies that AM equal to MB. So in the same ON is perpendicular to CD, so that in the chord CD we can take CN equal to ND. So in triangle OME and triangle ONE. So if we prove congruency of these two triangles by CPCT, we can say ME equal to NE. The corresponding segments are equal. That one thing we will get from this congruency part. So that first let me get the congruency of these two triangles OME and ONE. For that, by this perpendicular bisection, we can take AM equal to MB and CN equal to ND, and this line OE is the common side for both of the triangle. So OE equal to OE, because OE is the common side for both of the triangle. So each and every sides are equal. So we will get SSS congruency. By SSS congruency criteria, we can say that these two triangles are congruent. So triangle OME is congruent to the triangle ONE. So both of the triangles are congruent. By CPCT, we can say ME, because corresponding parts of congruent triangles are equal. So we can say ME equal to NE. It is given that AB equal to CD. Given that AB equal to CD. In this, if we subtract the parts, and we will take, given that AB equal to CD, if we multiply half on both sides, so half of AB equal to half of CD. This OM is the perpendicular bisector of this common chord AB. So half of AB we can take AM also. So half of AB is AM. The corresponding this side we can take DN. If we take the second half, this M is a perpendicular bisector, OM is a perpendicular bisector. So AM equal to BM and DN equal to CN. So AM equal to DN, we can say half of AB equal to half of CD. So half of AB we can consider AM, half of CD we can consider DN. The same way, the second half if we take, half of AB become BM. BM equal to half of CD become CN. So we are getting these two equality, AM, DN and BM, CN. BM, CN. And this is given. And one more thing, AE equal to DE. In this, we have AM equal to DN. In this, AM equal to DN. With AM, if we add these two equality, that means if we consider this is equation number 1 and this is equation number 2, if we add both 1 and 2, so AM plus ME equal to DN plus NE. It will become AM plus ME is AE. So AE equal to DE we will get. So we are getting this equality. So the corresponding segments of the chords of both of the equal chords are equal has been proved. Next question. If two equal chords of a circle intersect within the circle, prove that the line joining through the point of intersection of the center makes equal angles with the chord. And that means what is given? Two equal chords. The chords AB equal to CD is given. Two equal chords intersect at E. Two chords are intersecting at E. What you need to prove? Prove that the line joining the point of intersection to the center makes equal angle with the chord. So OE make equal angle with the chord. That means we have to prove angle OEA equal to angle OEB. This to be proved. You need to prove these two angles are equal. So these two angles are inside these two triangles. So if we prove the congruency of these two triangles, by CPCT itself we can say these two angles are equal. So in triangle OME and triangle ONE. So here OM and ON are perpendicular bisectors of both of the chord. So we can say ME equal to NE. And OE is the common side for both of the chords. And this OM is the perpendicular bisector of AB. OM is the perpendicular bisector of AB, which implies that angle OME equal to 90 degree. The same way, ON is the perpendicular bisector of AB, which implies that angle ONE also equal to 90 degree. Both are 90 degree. Because this line we draw now that it is the perpendicular bisector of the chord CD and this is the perpendicular bisector of the chord AB. So these two are 90 degree. So we can, right hand side is equal, we can equalize the left hand side, which implies that angle OME equal to angle ONE, both are also 90 degree. So we have 90 degree and the hypotenuse equality is there and the one side equality is there. So right angle hypotenuse side of one triangle is equal to right angle hypotenuse and side of the another triangle. So both of the triangles are congruent by RHS congruency criteria. So by RHS congruency criteria, triangle OME is congruent to the triangle ONE. So both of the triangles are congruent. So by corresponding parts of congruent triangles are equal, we can say angle OEM equal to angle OEN. We need to prove OEA equal to OED. So angle OEM is same thing as OEA. So instead of OEM, we can extend up to A also. So angle OEA equal to angle OED. So this line joining through the point of intersection of both of the chords to the center makes equal angles with the chord has been proved. Next one. If a line intersects two concentric circles, circle with the same center at the O, A, B, C and D are the points this line is intersecting. A common line, one line is intersecting the two concentric circles at the points A, B, C, D. So that we have to prove AB equal to CD. We need to prove this line segment AB equal to CD. So for this, let me draw one perpendicular bisector from the center. Perpendicular bisector from the center. So what will happen? The perpendicular bisector, draw perpendicular bisector OP. Let me keep this point as P. So OP to the line AD. So OP is the perpendicular bisector. From the center, it will bisect the chord. You know very well by theorem. The perpendicular bisector from the center of the circle bisect the chord. So if we consider AD as the chord and OP is the perpendicular bisector, so AT can be divided into AP equal to PD, because this perpendicular line drawn from the center of the circle will bisect the chord. So that AP equal to PD. And if we take the line segment BC, for this chord BC also, this OP is the perpendicular bisector. So this BC also, this chord divides into two equal parts. So BP equal to PC. Now let us subtract these two equations. So AP minus BP. So AP minus BP. In the right hand side, PD minus PC. So PD minus PC becomes CD. And this side it will become AB. So AB equal to CD. So we need to prove AB equal to CD. That has been proved. Next one. Three girls Reshma, Shalma and Mandip are playing a game by standing on a circle of radius 5 cm drawn in a park. So they are standing on a circle. Reshma, Shalma and Mandip. R for Reshma, S for Shalma and M for Mandip if we keep. And the radius of the circle is 5 cm. The circle drawn already in the park. These three girls are standing on the circle for playing. Reshma throws a ball to Shalma. Shalma to Mandip. Mandip to Reshma again. If the distance between Reshma and Shalma is 6 cm and Shalma and Mandip also 6 cm each. So both are having the distance of 6 cm each. What is the distance between Reshma and Mandip? So we need to find the distance RM we have to find. Length of the chord RM we have to find. Here O is the center. So that OS become the radius of the circle. OS is the radius, OR is the radius, and OM also become radius. So we need to find RM. So we need to find the length of RM. So for this, first let me take the triangle OPR and OPM. In triangle OPR and triangle OPM. So for in this triangle, if we prove the congruency, we can find about these two angles how they are. Okay. So let me find the congruency first of all. So here OR equal to OM because they are radius, both of the radii are equal. And OP is the common side for both of the triangle. So OP is the common side. And if we take the chords SR if we consider as a chord, okay, SR it is making SR and SM will make equal angles. So that vertically opposite angles are equal. Okay. SR and SM makes equal angles. Equal chords make equal angles at the center. SR and SM both also 6 cm. So both of the chords are equal 6 cm. SR and SM. This is R and this is S and this is M. So SR is first chord and SM is the second chord. Both also will make equal angles at the center. So this angle 1 equal to angle 2. This implies that angle 1 equal to angle 2. But if we take here angle 1 equal to angle 2, which implies that this angle OR equal to OM and OP is the common side. So we are getting side angle side. So by SAS congruency criteria, SAS congruency criteria, we can say triangle OPR is congruent to the triangle OPM. So that by CP, okay, corresponding parts of congruent triangles are equal, we can say angle OPR equal to angle OPM. So these two angles are equal and at the point P, these two angles will make linear pair. So at the point P, angle OPR plus angle OPM is 180 degree. Okay. Both are equal and total sum is 180 degree means each angle is 90 degree. Okay. So angle OPR equal to angle OPM equal to 90 degree each. So both also 90 degree. So that it is the perpendicular line. So it is making perpendicular line. So now we'll take OPR and PRS. Okay. So if these two are 90 degree, definitely these two also become 90 degree. So let me take these two triangles, PRS and PRO. The top two triangles let me take. So here R, S, this is the center and this is the point P. If this side is 90 degree, definitely here also it will make 90 degree. So both are right angle triangle and the distance between Reshma and Shalma is 6 cm and the radius of the circle is 5 cm. This we know very well now already, and this is 90 degree. So that we can substitute Pythagoras property in triangle PRS. In triangle PRS, so that SR square equal to so here OS is the radius. OS is the radius. OS can be written as OS is 5 centimeter. That means radius of the circle. So this OS can be split as OP plus PS. OP will be one side of this right angle triangle and PS is one side of this triangle. So if we consider PS equal to this OP equal to x centimeter. If OP will take x centimeter, then this PS can be 5 minus x centimeter. So OP is x centimeter and the PS is 5 minus x centimeter. So we can substitute Pythagoras theorem now in triangle PRS. The hypotenuse is SR square. So SR square equal to SP square plus RP square. So here SR square is 6 square equal to SP square is 5 minus x the whole square plus RP square. So RP only unknown. So if you bring to the left hand side, so RP square equal to 5 minus x the whole square minus 6 square. In the second triangle, PRS we have taken, let me take OPR. In triangle OPR, so the hypotenuse side square equal to OR square equal to OP square plus PR square. So OR is 5 square equal to OP square is x square plus PR is unknown. So let me keep as it is. This unknown let me bring to the left hand side. So PR square equal to x square minus 5 square. In both of this equation, this RP square, both are the left hand side is equal. So we can equalize the right hand side. So if we equalize the right hand side, 5 minus x the whole square minus 6 square equal to x square minus 5 square. Let me simplify now and we'll expand this bracket also. So 5 square is 25 plus x square minus 2 5s are 10x minus 6 square become 36 is equal to x square minus 25. This positive x square on both sides will get cancelled and the remaining will be this minus 10x equal to minus 25 plus 36 minus 25. Plus 25 to bring here it will become minus 25. Already minus 25 is here. So minus 25 become minus 15. So minus 10x equal to minus 50 minus plus 36 become 14. So this is equal to 14. So x is equal to, this is minus 14. So minus will get cancelled. X is equal to 14 by 10. It is nothing but 1.4. So x is 1.4. So that x, if we substitute here, we need to find the length of RP only. In RP is in terms of x. We got the value of x now. So that x value if you substitute here, what will get? We will get the length of RT. So let me substitute the x value here. Let me take this equation. This is little lengthy. So PR square equal to x square minus 5 square. Here if we substitute x value as 1.4, that 1.4 square minus 5 square. So 14 14s are 196. If we keep two decimal place, 1.96 we will get minus 25. So PR square if we bring here, this minus x square plus 5 square we will get. Both will get opposite sign. So minus plus, so minus x square and this also will get minus sign. So both of the signs will get cancelled. This is with the negative sign and this also if we consider with the negative sign. So both of the negative signs will nullify here. This sign and this sign will go and will continue as it is. And here we are getting minus of x square minus 5 square. That is minus of, so we will get minus if we subtract 25 minus 1.96, here it is 0, so 4, 0 and 23, so 23.04. It is having minus, so minus into minus become plus. The greater number sign is minus, so we'll get minus with minus sign only. Outside we have one minus already, so we'll get 23.4. So PR square is 23.4. So we need to get PR. PR means we have to take square root on both the side. If we take square root, approximately we will get 4.8 meter. 4 4s are 16. 5 5s are 25. So 5 times is not possible. So 4 times only will possible. 4 4s are 60. It will go 8 times remaining. So PR is 4.8 meter. We need to find here is the distance from Reshma to Mandip. This is nothing but PR plus PM. So this PR only we found now. Both also with equidistance. By this corresponding parts we have seen that PR equal to PM. PR equal to PM. So that we can take RM equal to PR plus PM, that is nothing but 2 times PR. So 2 times 4.8 we have to find out. So if you multiply 2 with 4.8, 16, 9.6 meter. So distance from Reshma to Mandip is 9.6 meters. Next question. A circular park. A circular park of radius 20 meter. So if we take O as the center, OS equal to OA equal to OD is 20 meter. 3 boys, Ankar, Syed and David are sitting at equal distance on its boundary. They are sitting on the boundary, each having a toy telephone in his hands to talk each other. Find the length of the string of each phone. These 3 boys are sitting on the boundary of the circle and they are having toy telephone each. So that we need to find the string of each phone. That means the length of AS and the length of AD and the length of SD we have to find. They are sitting with equal distance, so they are equal. AS equal to SD equal to AD. All of them are equal. If we consider this length as 2x, so that we need to find the 2x is what? So if we consider the length as 2x, so if we take the triangle ASM, in triangle ASM, here AS equal to, this is 2x, AS is 2x square, so AS is 2x and SM is half of SD. Here we need to get SM is nothing but half of SD. SD is 2x. So, 2x by x, 2 become x. So, SM is x. And ASM. Here, AM only unknown. AM is unknown. So, if we take this, so if it is an equilateral triangle, the line passes through the center from the opposite vertex. Definitely it is a perpendicular line. It will make perpendicular at angle M, at the point M. If we use Pythagoras property here, AS square equal to SM square plus AM square. So, AS is 2x the whole square equal to SM is x square plus AM is unknown. So, let me keep AM as it is. So, here 2x square, that is nothing but 4x square. This x square if you bring to the left hand side, we will get minus x square equal to AM square. That means 3x square equal to AM square. So, AM square equal to 3x square. If we take square root on both sides, we will get AM equal to root 3x. So, AM is root 3x. AM is root 3x. So, what is OM? OM is AM minus, if we subtract OA, we will get OM. So, OM is AM minus OA. AM now only we found AM is root 3x. Root 3x minus OA. OA is radius of the circle. Radius of the circle is 20 meters. So, 20 meter. Root 3x minus 20. This is nothing but OM. So, in triangle OSM, in triangle OSM, OS is 20 meter, that means radius of the circle 20 meter, and OM now only we found root 3x minus 20 meter, and SM is x. So, if we take on both sides, everything is in terms of x, so we can find the value of x. So, here at M is the right angle, so hypotenuse is OS. So, OS square equal to SM square plus OM square. So, SM square is nothing but 20 square equal to SM square is x square plus OM is root 3x minus 20 the whole square. So, if we simplify, this 20 square is 20 square become 400. equal to here x square, and let me clear this bracket also. So root 3 a minus b the whole square. So root 3x the whole square become 3x square plus again here 20 square. So it will become 400 minus 2ab. So it will become 40 root 3x. 40 root 3x. So it is this side positive 400, this side positive 100, 400 will get cancelled. So 0 equal to x square plus 3x square become 4x square minus 40 root 3x. So 4x square equal to 40 root 3x. So 1x will get cancelled. So that x is equal to 40 root 3 divided by 4. It will become 10 root 3. So value of x is 10 root 3. That means the length of the string is 10 root 3.